Let's dive right into this explainer. Imagine, for a second, a massive offshore jackup rig. We're talking a colossal structure of steel, machinery, and serious human ingenuity, usually pinned absolutely securely to the ocean floor. But what happens when it needs to move? Well, once those massive legs are pulled up and the hull is actually afloat in the open ocean, the game completely changes. The rig basically transforms from a sturdy, immovable island into a highly vulnerable vessel. The stakes are incredibly high, and today we're going to look exactly at how these marine giants actually survived the journey.
To navigate this safely, we rely on three core pillars of risk mitigation. First up, the muscle, which is our towing arrangements. Second, the structural threat, focusing on leg securing. And third, the human shield, or the hourly patrols.
Keep this foundational mindset with you as we go. Transit is the most sustained period of risk. The pre-move checklists might be totally done, the hull is afloat, but the transit itself, that can last anywhere from just a few hours to several weeks, totally depending on the distance. And throughout this entire window, the rig is at the absolute mercy of the sea. It is literally the most vulnerable it will ever be.
All right, part one, the muscle. Towing arrangements.
Moving a rig is definitely not a one-boat job. It requires a highly specialized fleet with two totally distinct roles. First, you've got the main tug, providing the brute force. This is typically a massive anchor-handling tug supply vessel, and it's connected straight to the front of the rig. Its one and only job is to provide that primary pulling power. But then, you have the escort or standby tug. Now this vessel is playing a completely different game. It hangs back, usually astern, providing absolutely crucial steering assistance just to hold the rig's heading against crosswinds or unpredictable currents. And even more importantly, if that main towing wire snaps, the escort tug is right there for emergency tow line deployment. Plus, it carries the primary rescue capability for any personnel emergencies.
The connection between the main tug and the rig is literally a lifeline. It's a heavily reinforced towing bracket welded directly to the hull, fitted with a massive shackle. But as you can guess, ocean towing isn't exactly a smooth ride. If the wire suddenly pulls tight in rolling waves, you get what we call dynamic snap loads. These massive spikes of force can easily equate to hundreds of tons of sudden, violent tension. Because of that, before the rig even moves an inch, these connections have to be physically inspected. Shackles must be moused, which basically means secured so the pin absolutely cannot back out. And every single foot of that wire is checked for kinks or excessive wear. Moving on to part two, the structural threat, leg securing.
So, how do we stop thousands of tons of steel from swinging in a rolling sea? Think about it. When the legs are pulled up for transit, they sit inside these guide frames in the hull. On flat, completely calm water, they look perfectly stable. But out in the open ocean, the hull inevitably begins to pitch and roll. Suddenly, the tops of those towering legs want to swing one way, while the bottoms are trying to stay put. You've got incredible lateral forces acting directly on the structure.
Without a rock-solid way to secure them, you run into a terrifying reality. Unsecured legs will violently pound against the inside of their guides with every single roll cycle of the waves. In moderate seas, this causes rapid, accelerating wear. But in heavy weather, it leads straight to catastrophic structural failure. The guide structures can be permanently destroyed, and that means when you finally arrive at your multi-million-dollar drilling site, the rig might be completely unable to jack up again. Literally, game over.
To prevent this kind of catastrophe, engineers have developed two primary solutions. First up, heavy wedges. And yeah, we're talking about thick pieces of timber or steel physically driven into gaps just to absorb those dynamic loads. Really think about that for a second. Millions of pounds of steel being held steady by strategically placed wooden blocks. It's kind of wild. But because they can vibrate loose over a long, bumpy journey, modern rigs rely really heavily on the second method, which are rack chucks. These are serious mechanical locking devices that engage directly with the rack teeth on the leg itself. Once a rack chock is engaged, that leg is mechanically locked. It cannot move vertically, it cannot move laterally. It's the absolute most reliable primary method we have.
But here is the absolutely crucial takeaway. Just having the equipment isn't enough. Leg securing must be physically confirmed by a competent person before departure. Actually, let me be clear, it is definitely not just a tick box exercise on a clipboard. It is a mandatory, physical, hands-on check. The survival of the rig entirely depends on this being done perfectly.
Which brings us to part 3, the human shield, hourly patrols.
Because Once that rig is moving, you can't just watch it from the bridge with a cup of coffee and wait to arrive. The rig has to be actively monitored. A designated crew member physically walks the rig every single hour, executing a really strict 5-point check. They're taking bilge soundings to check for any rising water. They're confirming every single watertight hatch is dogged down tight because sea motion can easily jar them loose. They're inspecting cargo lashings to make sure heavy chains haven't slipped. They're checking the towing wire for any chafing. And finally, they are logging their exact findings, signing their name, and recording the time. This routine is the rig's absolute first line of defense against the ocean.
Now, I want you to imagine something. It's 3 a.m., you're out on this patrol, and you drop your sounding tape down a bilge tube. You pull it up, and you see a specific number, a 15-centimeter rise in the water level since your last check just an hour ago. The situation has just escalated dramatically.
So what's the correct response here? Step 1 is detection, which you've just done. Step 2 is to immediately call the tow master on the radio. Not in 10 minutes, not after you casually finish the rest of your rounds. Immediately. Whether it's rising water indicating a flood, a loose cargo lashing that's shifting, or a chafed tow wire, this demands an urgent, coordinated response. The patrol crew member absolutely must have the discipline to escalate concerns instantly, regardless of what time of night it is.
Because it all comes back to this incredibly powerful core philosophy. A problem found early can be managed. The same problem found 4 hours later may be entirely beyond control. If that 15-centimeter rise in water goes unnoticed for 4 hours, the rig could list, take on way more water, and potentially capsize. Early detection saves rigs and, way more importantly, it saves lives.
Which leaves us with this final thought. We build these towering leviathans of extreme engineering, capable of drilling incredibly deep into the Earth's crust. Yet when they are at their most vulnerable, their survival essentially comes down to a block of wood wedged into a gap, a mechanical lock, and a single human being walking the decks with a flashlight every single hour. With millions of dollars and human lives depending on wooden wedges and hourly walks, is extreme engineering ever truly safe without extreme human vigilance? Really think about that delicate balance between machinery and discipline. It's fascinating. That wraps up our explainer for today. Keep learning, stay focused, and we'll catch you on the next one.